All right, welcome back to our continuation of our project. So I noticed that we have both of our servers in the same availability zone. So I mean, in part of the learnings that I've had is that when you're thinking of high availability, and things like single points of failure, you want to have your instances, spread out across different availability zones. So the thing with having both of them in the same availability zone is that in the event that this availability zone becomes unavailable, then you have no instances of your websites available to your customers. So I think we should try and fix that just for practice. So let's go back to our launch template and let's do this again. Let's launch another instance from our templates and let's see if we can select another availability zone. So we will use the same template like we did before. Just speed through this, scroll down, instance details, blah blah blah, instance type, keep here, networking, storage volumes, resource tags. I can't see an option to select another availability zone, so let's explore a bit more. Subnet info. Okay, so here we have subnet info. Okay, great. So here it is. So we can select the subnet or availability zone where we want to launch this new instance. So we had the previous web servers in US West 2A. So let's just do US West 2B. All right, so I think we can achieve what we want to here. So everything else remains the same. And let's launch the instance. Okay, successfully initiated launch. We want to go back to our EC2 instances. Let's refresh this. All right, so we have rename this now our new instance. It still works for our scenario, so Mason Web 03 -server. Okay, good. So we have another instance running now, and we have it in a different availability zone because that just gives us better availability in the event that one availability zone goes down. Okay. We can do a quick check, even though the status checks are not passed yet, but we should be able to view the website on the IP. Let's see, that will come up quickly. Yeah, so great. So we have another instance in a different availability zone, so we're able to fix that quite easily. All right, so we are through with that. So now we want to go on to the load balancer. So load balancers can be found on the EC2 portal. If you scroll down, you have here load balancers. Now, load balancers work hand in hand with target groups. So basically what a load balancer does is it sits in front of your web servers and your users are given an endpoint or a URL that points to the load balancer, and then the load balancer directs the traffic to the web servers, or in this case the websites that sit behind the load balancer, and the load balancer will distribute that traffic evenly between your web servers. So we have three web servers running with the same website. So let's start here with our target groups. So the load balancers work hand in hand with target groups, and what we will do here is to create a target group. We'll see how it all works together. So create a target group. We are dealing with instances. So our target type is the instances that we've created. You can also have IP addresses, Lambda functions. You can have another load balancer as a target for your for your target groups. So target group name will be Mason TG, and these are web servers, and our web servers are accessed on port 80, so we'll leave that. It's our default VPC. We have just the one, so we'll stick with our HTTP 1 protocol version. So these are the health checks. The load balancer will also perform health checks so that if any instance happens to be, or any server happens to be unavailable, it will direct the traffic to the available servers. So it's HTTP, so it's going to check via HTTP. This is the path. This is our slash. We can look at the advanced health check settings. So the health check is going to be performed on port 80. We can change that. The healthy threshold is 5. So the load balancer will perform 5 checks. And if the 5 checks pass successfully, then the server is considered to be healthy. If they don't, then the server will be considered an unhealthy target, and the traffic will be diverted to a healthy server. So we can reduce this just to make it a bit quicker. So unhealthy threshold remains 2. So if we have 2 consecutive health check failures, then the target is considered to be unhealthy. Timeouts 5 seconds. So the amount of time during which no response means a failed health check. So if there's no response from our servers in 5 seconds, then the health check will fail. The interval between health checks is 30 seconds, success code 200. So we'll leave all those as is, right? So that's target group settings. Go next. And available instances. So here we will see 3 servers, web 0, 1, 0, 2, and 0, 3. And these are the 3 servers that we want load balancer to work with. So select them all, and then we will include them as pending below. This is a step that sometimes you might skip over, but you need to click on that. And once you do that, your target groups will go into the review box here, and then we can just create our target group. So that's happening. Our target group has been created. We can see that here. We can see the details. Let me pull this up a bit. So our protocol port 80 load balancer, you can see here load balancer non-associated yet. So when we create the load balancer, we'll associate it with this target group so that the load balancer knows which instances to work with. So 3 targets, total healthy 0, unhealthy 0, unused, blah, blah, blah. Okay, these are the health checks. So like we set it up, 2 consecutive health check successes, and so on and so forth. Okay, so now we have that done. We will now go ahead to create our load balancer. So click on load balancers here. All right, so create load balancer. Now we have different types of load balancers: our application load balancer, network load balancer, and gateway load balancer. The load balancer, the application load balancer is the one we will need. That's the one that works best with web-facing applications with HTTP and HTTPS traffic as said here. We have network load balancers. Those are when you want a load balancer that handles high performance workloads and so on and so forth, and then a gateway load balancer when you need to deploy third-party virtual appliances. So we'll be working with the application load balancer. Let's create it. So our basic configuration load balancer name, we can call it Mason-ELB. So it's an internet-facing load balancer because our traffic is going to be coming from the internet into our load balancer. IP address type IPv4, our VPC. So here we are using our default VPC, and here we can select all the availability zones that we want to work with. So we have instances across 2 availability zones, but we can select as many availability zones as we want. So let's do that. Let's just select all the availability zones. We can add new servers to our target groups if we deem fit. So all availability zones selected here. Our security group. So our load balancers also work with the security group. So we'll create a security group for our load balancer. And this will take us to our security group portal. So here we can give the security group a name. So we can call it missing LBSG. Description: allow web access to load balancer. So that's our VPC, our inbound rule. So let's add the rule. So what we want is HTTP access, that's web access. That's always on port 80, and we want source from anywhere. So we want to allow access to our load balancer from over the internet, anywhere, IPv4. Okay, and we can do an additional rule: HTTP over the internet, anywhere, IPv6, just to take care of both those options. We won't touch our outbound rules. And I think that's it. We create our security group. So that's done. Let's go back to our load balancer portal. Select our newly created security group. Okay, apparently I had one created before. So let's do this. We can take this one away. Like I said, missing ALB security group, so that's the one we've selected. Listeners and routing is going to be listening on port 80. That's the HTTP web portal. Now, default action. So what we are saying here is that any traffic that's coming in on port 80, forward it to the missing target group. Now remember that the missing target group has sitting in it our 3 web server instances. So that's what the load balancer will do. It will take the incoming traffic and distribute it among our 3 instances. So that's it. Listener tags, listener summary, blah blah blah, and let's create our load balancer. So our load balancer is created. Let's view our load balancer, and we have our load balancer in a provisioning state. So this video is getting a bit long, 13 minutes. So we'll come back in a new video when our load balancer is fully provisioned, and then we can attempt to access our websites via the load balancer endpoints, which will be this DNS name here. Okay, everyone, see you on the next video. Thank you for watching.